Hello, as I said during our 301 lesson, Unit 3 is about taking two sets of data and matching them together. So in Unit 2, we looked at univariate, one variable, and now we're looking at bivariate, so we're going to have two variables going on at a time. So we're going to look at some two-way tables, try to create some, as well as interpret what they mean. So again, when data has several categories, we're going to have to make our tables just a little bit more complicated. We can't just do a simple bar graph as we were in Unit 2. We're going to have some tables and graphs we'll see today to present the data, to show it, so that other people can interpret what it means. So here's a very simple example of a two-way table. This would be if we were looking at milk and soft drink consumption based on age. So you can see the two categories here. The first category is over here, going across in our rows. That would be milk and soft drinks. I don't know why water isn't consumed here. I hope water should be listed there. But they're just looking at milk and soft drinks in this one. And then we have age categories going up and down in our columns. So this would be how old they are by years. So you can see that there's multiple categories going on. There's milk and soft drinks versus the age categories. So that's our two variables. And then inside these, you'll see how many servings they're having. This isn't how many kids, it's how many servings they, I don't know if this is suggested or realistic. So you can see, for example, like a 1 to 3-year-old is having 1.4 servings of milk and 0.6 servings of soft drinks. That would be like soda. And then you can see that as they get older, their consumption of milk tends to decrease. And maybe this is fitting for yourself. And then also as they get older, their consumption of soft drinks are going up. So you can look at any particular time frame. For example, if I said how many servings of milk are 9 to 13-year-olds having, then you'd go to 9 to 13 and milk and see where they intersect, and that would be right there with the 0.9. So that's just a simple example of a two-way table. You can make your own two-way table. This will be kind of interesting. I'm going to freehand this, so I hope these lines come up relatively straight. So your first thing when you're trying to create your own two-way table is to identify the variables and categories so you can set up the table. So in this case, I see we've got JV, junior varsity, and then we've got the varsity team. So that's one category is the type of team. And then the variables inside, or sorry, let me flip that. The variable is the type of team and the category is junior and just varsity. So if I were creating this two-way table, I'd start off with, and it doesn't matter which one goes on, like vertical versus horizontal, doesn't really matter. There isn't a clear way to decide it, so you could flip this around if you chose to put them vertical versus horizontal, it'd be totally fine. So I've got the type of team going on over here. I'm just going to draw a little division there and give myself another division. We're going to try for straight lines here. And then the thing about the JV versus varsity is the games. So we're looking at win, lose, and tie. So the result of the game. So up here I'm going to say W for win, and then go ahead and whoosh, and then lost, whoop, and then tie over here. And you can go ahead and surround your table if you want to. You're going to find most of them are completed tables, so they're all knitted up. Oop, let's get all my lines to meet up. There we go. All right, and then I'm going to grab a different color to write in the numbers. Let's go with a lovely red color. So it tells me, let's see, the junior varsity team played 12 games this season. They won 7, so right there in JV and win, I'm going to put that. Lost 3 and tied the rest. Well, it doesn't tell me, but they have 12 total. So 7 plus 3 is 10. That means they must have tied 2. Let's see, the varsity team played 14 games. They won 10 of them and lost the rest. Okay. And so lost the rest, that'd be 4 since they had 14 total, and that means they had no ties. All right, so there would be an example of creating my own two-way table. Again, I realized that JV and varsity, and then up on the top I put win, lost, and tie. You could have flipped that and put the win, lose, or tie on, you know, the horizontal. It wouldn't have mattered. It would just be flipped around. All right, so let's look at interpreting them, reading them. So how many children saw the afternoon show? There's some show, child, adult, and senior citizen. So you want to find an intersection of children and afternoon show. Where do those intersect? And the correct answer is right there. That would be 30. 30 children saw the afternoon show. Same chart, we're just going to look at a slightly different question. What percent of the adults? Okay, so when you're asked for percent, you're going to want a total amount. So it's percent of the adults. So you need a total amount of adults. And so I'm going to go 20 plus 50, so that's 70. I have 70 adults going to these shows. So what percent of the adults went to the afternoon show? Well, 50 of those 70 went to the afternoon show. So I'm going to go 50 over 70. I'm going to want a percent, so I'm going to go ahead and multiply by 100. And I'm going to grab my calculator real fast. I think that's in the 60s. Let me grab my calculator. So 50 divided by 70. Oh, 70s. I was off. Times 100. And I'm going to go ahead and round that to the second decimal point. So that's 71.4. It's 2 8, so that 8 pushes my 2 up to a 3. So 71.43%. So vast majority of the adults went to the afternoon show. Maybe they were at work in the morning show. I don't know. What is the ratio? Same chart. What is the ratio of the adults who went to the morning show to adults who went to the afternoon show? So remember with the ratio, we don't like multiply by the 100. We're just looking at a comparison of the two. So, and you always go in the order that they're stated. So you go morning to afternoon. So adults who went to the morning show, that's 20. To adults who went to the afternoon show, that's 50. That's 20 to 50. Simplify with ratios if you can. Notice I have both of those divisible by 10. So I'm going to say 2 to 5. You could also put this in 2 to 5 in a fraction form. So it's 2 to 5 ratio of adults who went to the morning show to adults who went to the afternoon show. What percent of the people at the morning show were senior citizens? So be careful with percents that you need to know what's the total. It should be the phrase or the word that's following percent of. So what percent of the people at the morning show? That's the total I'm looking for. So I need to total up the morning show. 10 plus 20 plus 10 is 40. So there's 40 people at the morning show. How many of them are senior citizens? 10 of them are senior citizens. So I'm going to go 10 over the total of 40. Again, with a percent, I'm going to multiply by 100. And I can do that one in my head. That's 25%. So 25% of the people at the morning show were senior citizens. Another way to show it, and this is going back to the soft drink and milk, this is called a stacked bar graph. So you take the categories, in this case the age down at the bottom, and you give different colors. I know these aren't vastly different. It's just a dark green and a light green. You could do different colors. You don't have to do the same, like have it be all monochromatic or something. You can do totally different colors. And so you show on the same vertical bar the values for each. Some drawbacks to this one and some pros. Some pros is it nicely adds them together for you. So I can tell that 1 to 3-year-olds are getting about 2 servings a day. And I can tell that 4 to 8-year-olds are getting about 2 servings a day. And I can see that 9 to 13-year-olds are getting more drinks per day. I mean, it makes sense when you're larger, you tend to need to drink more. So 9 to 13 there, it looks like they're getting about 2.4, and then about 3.4 for our 14 to 18-year-olds. So that's a pro. It adds them together for me. And you can see that nice trend of, oh, it looks like they're drinking more beverages overall, leaving out water. Hopefully water is in here somewhere. The drawback is your second, the top one, you need to start doing some subtraction. So that's really the big drawback, is you have to do some subtraction. So for example, milk is the one down below. So these are all the milk consumptions. And then the dark one is the soft drinks. So here's the sodas. I call them soda, depending on where you were raised. My mother-in-law calls them pop. My husband calls it soda. My kids call it soda. Really, I think it's just where you were raised. Anyway, so with, for example, in the 1 to 3-year-olds, you have to start going, okay, so milk is about 1.4, so that means 1.4 to 2 is 0.6, so that means that soft drinks is about 0.6, and so that's like the only really significant drawback to this, is that you have to start, especially when you get more than just like 2 categories, you have to start doing a lot of subtraction, but it's nice to see comparisons. You can really tell, like, oh wow, this soft drink is far larger than the milk down here. Whereas here you can see, oh, 4 to 8, they're roughly the same. So there are some drawbacks, some good things, but this is called a stacked bar graph, because they're stacked on top of each other. So let's look at interpreting it. This is the afternoon and morning show. So it's the same as previous. So which age group had the highest total attendance? That is something that is easiest to see with this, because they're all ordered to get, added together for you. So the highest total attendance right here is adult. That makes sense. Children need to be with somebody. So the adults, senior citizens are, I don't know, maybe a little bit busy. I don't know. So the adults, make sense that they would have the highest total attendance. So that would be adult. Which age group had the highest ratio of afternoon attendance? So highest ratio of afternoon attendance. I would take that, since it's saying ratio, I would take that to mean like afternoon to morning. So for example, children, it's 10 to 30. Flip that around. Afternoon's the pink. So I'd go 30 to 10 for the children. I'll put a C for that. And then adults, that would be, they had 50 to 20. So this is going to come out to 3. This is going to come out to 2.5. Oh, not 2.5. No, is that? Yeah, sorry. That's right. And that's for adults. And then senior citizens, who are the least likely to go to this. They've got the smallest one, and they'd be 20 to 10. And that comes out to 2. So the highest ratio of afternoon attendance would be that children. More children are there. And then which show did 2/3 of the senior citizens attend? So on this one, you don't even care about adult and children. You're just looking at senior citizens right here. So 2/3, that's the greater majority of the senior citizens. So when you look at this stack here, you're looking for the one that's the bigger of the 2 colors, which in this case, it's obvious that the pink right here is the bigger. So senior citizens were in larger attendance in the afternoon show. Okay, we can also show it in a double bar graph. Some pros and cons again to double bar graph. You don't have to do as much subtraction. It's just interpreting, like, or reading where they hit. So 0.6, this is 1.4. Didn't have to do any subtraction to figure that out. It's really nice to see the comparisons. For example, on this one, you see, hey, it looks like these 2 are the exact same. So soft drinks and milk for 4 to 8-year-olds are relatively like the same servings. You can see, oh, it looks like Comparison of 9 to 13-year-olds, soft drinks are winning. And you can see a stark comparison here. It looks like they're almost drinking about the same amount of milk, a little bit less milk, but their soft drink consumption is greatly increased. So double bar graphs are really nice to see comparisons between the individual categories, not necessarily a trend over all of the years. So it doesn't quite help me as much as a stacked bar graph to see that they were increasing the overall consumption of beverages as they aged, but it definitely helped me see, oh, it looks like milk is higher, now they're equal. And then soft drinks is higher, and now soft drinks are a lot higher when we get to the teenage years. So a little bit of practice here, comparing Destiny and Mariah. So in an election, Greenwell and Wong were the only candidates running for public office. Yay. The two-way table shows the number of votes they received. So they have the 4 districts up here, the 2 candidates on the left. Students were asked what % of votes in District B did Wong receive? So you're just looking at District B. Again, when it says what % of, pay attention to the next phrase or word. So next phrase is votes in District B. That's your total. You need to add up that category. So 710 plus 682 would be 1392. That's the total in District B. And then we're looking for Wong. How many did Wong receive? And that'd be the 682. So when you look down here, both Destiny and Mariah solved this. Which one did it correctly? And the correct answer is Mariah. So it looks like Wong got about 49% of those votes. Destiny found a comparison between the two. So Destiny's was wrong. This is a ratio. So Destiny found the ratio of Wong's votes to Greenwell's votes in District B, but did not total up. So didn't find a % of the total there. Cool. Should have taken that one out. Take as many minutes as you want. And the password is Gustin. Have a wonderful Friday. And if I'm at testing, please say hi to me.